Let us construct an ellipse with eccentricity is equal to 2 by 3 and focus distance is 50 mm. First, let us draw one directrix or a vertical line. Now we can draw one axis of the ellipse. Now this is the directrix. So the focus distance we have to mark from the directrix as 50 mm, which is given in the problem. Now at 50 mm I can mark a focus F. Now the eccentricity is 2 by 3. So at the vertex point, this side distance should be 2 times, and from the directrix to the vertex point is 3 times. Then only we will be getting the eccentricity of 2 by 3. So we can divide this into 5 equal parts, that is 2 plus 3. Then we can mark the vertex as easily 1, 2, 3, 4 and 5. Now when you mark this vertex point here, this side will be 2 times and this side will be 3 times. 2 by 3 will be followed. Now from this vertex point we can draw one vertical line. Now we have to transfer this VF distance on this vertical line. How we can do? We can just mark this needle at V, and you can just mark this F, and then you can rotate this compass and transfer this distance on this vertical line. So this point is going to be E. Now we have to join this C as well as E and extend it. I will just repeat. We have drawn the vertex and then the axis of the ellipse. Now we are marking this F at the distance of 50 mm from the directrix. This is 50 mm. Now we divide this focus distance CF into 5 number of equal parts, that is 2 plus 3. That means when the eccentricity is given as 2 by 3. Now we can mark the vertex so that this side is 2 centimeters, this side is 3 centimeters. That means we have got our 2 by 3 ratio is maintained. Now after this vertex we can have any number of points at any distance. That need not be equal distance. So let us say this 1 centimeter distance we can just mark certain points, or randomly also we can mark certain points. Like this we can just mark some points to find out the points in the ellipse. So these points we can name it as 1 and 1 dash, 2, 2 dash, 3, 3 dash, 4 and 4 dash, etc. Now what we can do is we can take the radius of 1 dash. Take the radius is equal to R will be equal to 1 dash and center as F. And then from this F as center you can just draw 2 points cutting your vertical line. So these points are called P1 and P1 dash. Similarly, you can take 2 dash radius, 2 dash radius, and then from F 2 dash radius, and from F we can cut this point at 2 points, that is P2 as well as P2 dash. This is P2 as well as P2 dash. Similarly 3 dash, we can repeat this step for any number of points. From F we have to cut here as well as here. Similarly 4 dash, from F we can cut these points on this vertical line. Similarly this 5 dash, from F we can mark here as well as here. And then 6 dash, from F we can mark here as well as here. Now we can see the curve is just converging, so it is going to be an ellipse. Now this distance 7 dash, you can mark these two cutting points. Similarly this one, and then from this F I am just cutting here as well as here, so it is going to be this. Still few more points we need to complete this ellipse, so we can draw few more points like this. We can extend this line also. This is trial and error method only. We can just see when it converges. From this F we can draw here as well as here. So it comes here as well as here. Now we need some more lines to be generated. Here as well as here. Now we can just find this distance, so it's very close. So this point and this point, maybe the curve may be crossing here. Now these points we have to join by a smooth curve. When you are not able to draw a smooth curve, we can use this French curve. In this one, this French curve, what is the approximate curve we can have? We can just draw like this. We have to find the approximate curve like this. Otherwise, we can draw a freehand curve also like this. So this freehand curve can be completed like this. This is how we can complete the ellipse. For this ellipse, if we want to draw a tangent and normal from any point, suppose if you want to draw a tangent normal through this point P, the procedure is, first we have to draw a joining line with F and this P point. Now from this F you draw a perpendicular bisector, or you can use this set square like this, or simply you can draw this line, or what you can do is you can make or use the mini drafter and then make this line parallel and then keep it from F and then join this, so it is cutting at this point. So this point and the P, when you just join, that is going to be a tangent from that point. So this is the tangent line T. When you want the normal, it's very easy. Just make the minute after n parallel to this tangent line. Now bring this other limb through this point, and this is going to be a normal. The normal and tangent should be 90 degrees. This is normal and tangent. From any point we can just draw the tangent and normal using this procedure. If there is any point, join with F and then draw a 90 degree line. From that point you can just join, you will be getting your tangent. So this is how we have to construct the ellipse. So in the next video I will just explain how to construct ellipse, parabola as well as hyperbola.